So just to do a quick review, oh, and this should be like a 2 out of 3 parter because I do have a meeting in a little bit. The reason why we just add them together is because if it's only 30 degrees, there's not really an opposite thing happening here. And it's saying from the positive x-axis. So that means that you would be able to add this and this. So that's why this video ended really weird last time. So let's move on to the next one. All right, and then this one is just a logo. I don't know why. Sometimes they just do these slides randomly. All right, so moving on. Now we're going to use vectors in the real world. So, vectors in the real world. So, whenever we're talking about this, a cosine when we're talking about an angle, a cosine is always going to be referring to the x value because it's opposite over hypotenuse. The hypotenuse is our radius. And our cosine is basically, we're going to divide it by the magnitude, the length of r, essentially. And our sine is always going to be talking about the opposite, which is our y value. So if this is our angle, opposite is y. Cosine our adjacent is x. So if we want to find the component form of a vector, it would be r is equal to xy. And the way it's set up would be the magnitude, however long this r is, times cosine of the angle. And these two angles are the same thing. So that's why there's two different trig functions. One to use this angle to solve for x, one to use this angle to solve for y. All right, so now we can figure components of vector. So vectors, when it comes to magnitude, in this case, the magnitude is talking about a speed, and the degree is talking about how far we're going north, south, east, and west. So in this case, so it'll tell us the direction. So normally, I think what they do is they do it based off of north, and if you're like 30 degrees west, you would go like this. And if you're going at a certain speed, it tells you like how hard you're going, how fast you're going. That would be your R. So this will allow you to say like, oh, you're traveling so fast to the westwards, even though you're going this. So if you're going like 100 miles an hour, you are traveling east. You're just not traveling as far east because some of that speed is going towards going south. And I kept saying east, this is west. So you would be going west, but some of your speed is being used up. And they even says it right here. So some of it's being used. So let's see how this would go here. So to the equivalent direction, we count degrees counterclockwise. The direction of this. So, whenever we're talking about counterclockwise, remember how we count our quadrants: 1, 2, 3, 4. So, 1, 2. So, that's counterclockwise. So, whenever we're talking about a direction, we want to go this way. So, this would be 205 degrees. And the reason why it matters is because in a calculator, it'll affect the negative and the positive. Positive being north, the other positive being east. So let's say in this case, we're rotating this way. Um, the fact that we're doing 205 degrees is going to make it negative. So this, by knowing how far we're rotating, this lets us know that the x value is negative as well as the y value. So the reason why magnitude is done in absolutes is because you don't go like I'm traveling negative 100 miles an hour. You just say I'm traveling 100 miles an hour. I guess in this one it's 95 miles an hour. But the positive and negatives do help in the sense of like, well, what direction are we going? So that's where we're going to use these types of coordinates with positives and negatives. All right, so let's take a look at this one. So a boat's traveling 30 degrees north of west. So north of west. So if we look here, so we're going west, 30 degrees north of west. So that would be this way. All right. And then what we want to do is we want to find our R. So boat travels 30 degrees at a 10 miles an hour. 10 miles an hour. All right. So if we want to do this, what we're going to have to do is recognize that this isn't 30 degrees, it's 30 degrees north of west. So everything else here, oops, get my thing here. So this right here would be whatever's left from our actual angle, which would be east. So we're going to do 180 minus those 30 degrees, which will give us 150. So with that 150 being said, now we need to find our components. So the magnitude in this case is 10. So when we're looking for x, we're looking for 10, which is our magnitude, times our cosine of 150. So we're going to have to use Desmos for this. So we're going to use the Desmos scientific calculator. It's going to be 10 cosine of 150. And we're going to end up getting negative 8.66. Let me see how many decimal places. Negative 8 point, oh, negative 8.66. Which makes sense because if you look at it, x would be going negative. It's going west. And then now we want to do it for sine. So it's still that, but now we need a y value. So we're going to do it for sine. And we get a positive 5, which again makes sense because we're going north, which is a positive direction. So that's how you would find these in real life. And again, you always want to do it based off of west is always going to be 0 degrees essentially when we're calculating it out mathematically. Different things are different. So if you're flying like an airplane, sometimes they say north is 0 degrees. But in a coordinate plane, we're just going to say that east is always 0 degrees, which means west would be 180. All right, so moving on from here. So this is how they do it. And then there's clockwise and counterclockwise. So bearing, it's saying the bearing from north, basically. So that's what it means by bearing is they're going clockwise. So bearings differ in directions, which means counterclockwise from the positive x-axis. Counterclockwise from the positive x-axis. Or clockwise. So from a positive x-axis. However, not all angles see the real world. Again, this is like what I was saying that it just depends on what you're using as your reference point because operations we must convert all bearings in degrees direction. So yeah, basically what I just said, we have to because of how the maps are, we're gonna have to do it that way. And tangent. So tangent is just a way for us to basically calculate our angle. So if we know we're going uh, east a certain amount and we know we're going north a certain amount, we would be able to figure out our R. So tangent's just an easier way for us to calculate our theta. If we don't know what our theta is, we're just going to use components. And looking at that, going to the next one. So let's get this activity done. Let's see here what they're talking about. So write a vector P in component form. So component form again, if we're talking about component form, that's the magnitude cosine x, comma, the magnitude sine. I said x, sorry, theta. I need to get better at that. Theta, sine theta. So that's how you would write it down. So let's kind of see what information they're giving us here. So an airplane is traveling 400 degree or 400 at a degree 30 degrees north of west. So west again is this 30 degrees north of west. So this again is 150 degrees because we're subtracting it from 180. So that's 150 degrees right there. Okay, and we want to round it to the nearest hundredths. So this is very similar to the one we just did. So I don't know why we're doing this, but okay. So we're gonna do this. Let me write my brackets, and we're gonna write it as 400 cosine of 150, comma 400 sine of 150. And then we would just plug this into Desmos, and it asks to the nearest hundredths, I believe. Hundredths would be two decimal places. So doing this, 400 cosine. Oh, you know what? The speed was different. That's one thing. Okay. So negative, and luckily I can just copy and paste that because it doesn't round up. So I'm just gonna grab that, paste it here, comma, and then I'm going to do the same thing for sine. So give me a second here. I need to do this for sine. 200. All right, so let's do this. And this is 200. Oops. 200 even, it looks like. So let's do that. Submit it. Let's see how we did. Yep. So you see here that that's what we're doing. Write the vector v as component answer. Vector w. What is vector w? Is it referring to west? P. Write the winds in vector form. Wind. What wind? The airplane traveling the ship. The wind is blowing. Okay, so I didn't read this part about the wind. Okay, so now we need to do this part, and it's 60 miles an hour. All right, so let's kind of draw this. And it is 30 degrees east of north. So here's north, and it is 30 degrees east of north. So east would be this way. So if this is 30 degrees, then we're going to be talking about a theta of 60 degrees. So we're talking about theta of 60 degrees. So let's kind of get into that. So when we're writing this down, actually, I don't even think I don't need the equation editor. We would write down 60, it's 60 miles an hour. Yep. And it's 30 degrees. So 60 miles an hour. And it's also, I said 30 degrees, but it's 30 degrees. So 30 degrees east of north, which is 60 degrees from the actual east. And then this is going to be 60 sine 60. All right. And this is going to be. All right, so I'm going to change this to 60 cosine 60, and we get 30. So we get 30, comma, and it's the nearest hundredths if we need it. And this will be sine. So this one will be, and we don't have to round up again. So luckily I can just copy and paste this again. paste that. And let's see how we did. Yep, right on the money. All right, so now we want to find the sum of these two vectors together. So the sum of the vectors gives a resultant of the wind force. Add the vectors and get the resultant vector. Okay, so I'm gonna copy my answers for the wind and the other thing just to make it a little easier on me. And because I use equation editor, unfortunately I have to do it this way. See? Go in here. Paste that there. Oops. No, of course. Why would it make it easy on me? Um, okay. So let me do some quick editing here. So we're gonna have to do with the equation editor because I done goofed. That's fine. Okay. So now I want to add these together. So here, let me grab the little calculator. Negative 346.41. And we're going to add that to 30. So negative, oh, that's actually pretty easy to do in your head. Negative 16.41, comma, 251.96. And that's the sum of them together. So we get the same answer, nice and simple. Find the actual speed. So if we want to find the actual speed, we need to find the magnitude. And the way we're going to find the magnitude is we're going to square these and add them together. So what I'm going to do here is I'm going to go back in here. And now I'm going to, did this not edit? Okay. It's just Edmentum being Edmentum. And I'm going to change this to a multiplication. I'm going to square it. And I am going to do this, square it. And all of this needs to be square rooted. So I'm going to copy all this and paste it under here. All right. And we're going to need calculators for this, obviously. So I think this might be enough, but unfortunately, it's like you have to do it step by step. So the negative doesn't really matter because we're squaring it. So we're gonna and I'm gonna do times. I just realized that I don't know where the square button is on this. Oh my gosh. Is there a square button here? There is. Okay. So 1 point. Ah, I'm sorry, guys. 0.45. And we're gonna square that. So we end up getting 1, 2, 2 plus, and all of this has to be square rooted. Plus, let me clear this out. 251. I do prefer using Desmos, but just because this is on the same screen, it allows me to just not have to keep going back and forth repeating numbers. Okay, and this is gonna be As you can see, it's like I'm having trouble even though it's on the same screen. 84. I'm just doing two decimal places, so one. So that's the resulting thing, and then I'm going to take the square root of that, which is 404.4. Okay, so we have this. So you can see the wind's kind of actually giving it a little bit of a boost, it looks like. So if we look at the plane itself we said was only going 400. So because the wind's blowing north as well, it's giving it that bit of a boost. So that's why I remember when I said if you add the vectors together, um, it's always going to be smaller than if you did it together. But find the actual direction of the plane. Okay, so in order to do this, we're going to have to do the magnitude. And so our magnitude is 404.7. And we need to multiply this by, what was it? What's the overall direction? The wind blowing from the east. Find the actual direction of the plane. So, oh, this is where we have to use tangent. Oh my gosh. So, in order to do this, I was like, wait, where are we getting this data from? Okay, so theta, remember, equals inverse tangent, tangent inverse of, we're going to have a fraction here. And that fraction is going to be our components. And our components, as we saw, were over here, are going to be our y value is on top, which is 251.96 over negative 16.41. All right. And now we're going to enter all of this into Desmos. So go here, go to function, inverse function, and we're going to type this in. I don't know if how nice this is going to be, so I'm going to just do the numbers individually. Nope, I can't even copy numbers correctly. Come on, Edmentum. Uh, I'm going to get in trouble if Edmentum ever sees these videos. All right. Which I shouldn't because it should be, hey, look at all these issues with simple text editors. Okay. This. So we end up getting about negative 38.56. Did I forget a negative somewhere? I probably forgot a negative somewhere. Nope. It doesn't look like I did. So, um, negative 38. Degrees. Let's see how we did here. Yep. So there we go. So the wind is pushing it a little bit. Does the resultant that you got in E make logical sense in the scenario? To me, it kind of doesn't because hold on. If the wind's blowing this way and that, it wouldn't make sense. Because if we're going this way, the wind's blowing this way. and we're going down here. So let's say no, it wouldn't, because the and it wouldn't make sense because airplane is going south. So imagine in the next slide, and I'm running late to another meeting, but in the next slide we'll talk about it. So I'll end this here, and then I'll finish it in a second. Well, I'm going to continue recording. So it wouldn't make sense because if we think about it, negative 38 degrees is going down. So it going down, like if the airplane's going this way and the wind's going this way, why is the airplane going down? So it wouldn't make sense um, going south when there is no force pushing it south. So let's see what the yes, the result makes logical sense. No, it doesn't. What are we talking about here? Um, degrees. Oh, but we're doing that from 180. Okay, going south. Um, so but since this is um from north. So because it's from north, that's where I messed up here. So the x value and the y value is positive, resulting in this. We get a theta here, and we still need to do this from a 180. Wait, that degree. That. So yeah, it's a little weird. So doing this, we get this negative angle here. Oh, give me a second.